So let's look at the reactions that these Aryldiazoniums can do now, because like I said, they're really synthetically useful reactions. This would be a really exciting moment if we were in class, because this is actually your last section of the chapter, of the quarter, of the whole entire year. So these reactions are aromatic reactions. These are going to be like aromatic substitution reactions. These are going to give us the versatility to put all different kinds of substituents on an aromatic ring. So I'm going to start with just the Aryldiazonium. I'm going to write it as N2+, but remember it looks like this. And we have, it looks like about 8 of these different reactions that we can do. So you can use this reaction if you want to put a bromine on an aromatic ring. Even though we do already know how to put a bromine on an aromatic ring, this would be another way to go about doing it with copper 1 bromide. You could also use this reaction to put a chlorine on an aromatic ring, and I know that's not exciting because you already know how to do that as well. But what about iodide? This reaction will put an iodide on the ring, and that's something that we don't know how to do. Also, we can use this reaction to put a cyanide on the ring. And I hope that you can see kind of the pattern of what I'm doing here. I'm not going to continue to redraw the Aryldiazonium all the way down, but it's the same reagent every time. So we can put a cyanide on the ring, so that's something we don't already know how to do. And then don't forget that you can hydrolyze cyanide. So H3O+ with some heat, and it will convert that nitrile group to a carboxylic acid group. So there's another way that you could make benzoic acid that's maybe a little bit easier than the side chain oxidation. We can even put a fluorine on the ring, HbF4, which it's a crazy reagent, but if you really wanted a fluorine on there, there you go. You can put an OH group on the ring easily with water and a little bit of heat. And so here is how you could make a phenol. Also, you could remove that N2 group with H3PO2. That's a really weird acid, but that's going to take that group right off. So if for some reason you needed to strip it down to just a plain old benzene ring, now you have 2 different ways that you could do it. And then last but not least, you could attach that Aryldiazonium to another aromatic ring. And this would create what we call a coupled aromatic product. Oh, I lost a nitrogen there. So I think for this one, I am going to redraw the original Aryldiazonium just because it's so far up the screen. So for this, here's our original, and here is where it is in the product, and then we are bringing in this new aromatic group. And the R group that's attached to that reactant that we're bringing in could be a variety of different things. It could be another amino group. It could be an OH group. It could be an alkoxy group. It could be an ester, or it could just be another R group. The only thing it can't be is just a plain old hydrogen. There needs to be something out there. These molecules right here are azo compounds. And they're very colorful, usually, because they're very conjugated. They've got all these double bonds in the ring, and then in the nitrogen-nitrogen double bond, and then out of the ring as well. So because they're highly conjugated, they're highly colored. And synthesizing an azo compound, synthesizing an azo dye would be the last lab that we would do in class. All those flags that you see above the hoods, those are all flag things that have been dyed by an azo compound that a student created by mixing and matching the molecules that are put together to make this particular compound. In addition to having options with the R group out here, you also do have some options with what kind of substituents you would want to put on the original Aryldiazonium. So that is your last set of reactions. I'm going to draw you a celebratory picture.